Okay, welcome to Tungal online classes. In previous video we had discussed what do you mean by position time graph, what do you mean by velocity time graph, and what do you mean by the acceleration time graph and its applications So in this video we are going to discuss the equation of motions by graphical method. Okay, so there are four equations. The first one is v is equal to u plus at, and second one is s is equal to ut plus half at square, and the third one is v square minus u square is equal to 2as, and the last one is the displacement of the particle in the nth second, that is equal to u plus a by 2 bracket of 2n minus 1. Okay, the first one is v is equal to u plus at. V is equal to u plus at. Okay, in this case v indicates that the final velocity of an object, u indicates that initial velocity of an object, a indicates that acceleration, and t indicates that time. Okay, see here in this case we are considering an object or a particle. It is moving with the initial velocity u, and uniform acceleration a. Suppose v be the final velocity of an object after t seconds. Okay, see here. So here we are drawing a velocity time graph of an object is moving with a uniform acceleration. Okay, see here. So in this graph, this a b point gives, or it represents, the motion of an object with a uniform acceleration. So here this y-axis is velocity and the x-axis is, that is, time interval. Okay, the next one we are joining this point. Okay, the next one, draw AC perpendicular to the BD. So after that join this point. Okay, see here, this is the origin. So this graph represents that particle is moving with the initial velocity at t is equal to 0 second. So that means this gives the initial velocity, that is u. And it is parallel to, OA is parallel to the DC, so this also gives the initial velocity, that is u, right? After that OD, so OD indicates that time interval, so this is the time interval t. OD is parallel to the AC and this also gives the time interval t. And this point B, it represents the final velocity of an object, that is v. This is the final velocity of an object is v. Then see here, the BD value is v and CD value is u. Then what is the value of BC here? So that is v minus u. So the value of BC is, that is, v minus u. Okay, see here. So first we will write all the values here. That is OA is equal to, that is equal to CD is equal to initial velocity, that is u. After that OD is equal to AC is equal to, that is t. So after that BC is equal to v minus u. Then BD is equal to final velocity, that is v. Okay, see here. We know that the slope of velocity time graph, gives acceleration. Okay, see here. So in this case, slope, that is equal to, slope is nothing but, that is BC divided by AC. Slope is equal to BC divided by AC, right? Okay, so here the slope of an velocity time graph gives the acceleration means instead of slope we will replace by that one is the acceleration a. Then BC value is v minus u, BC value is v minus u divided by AC value is that is t, AC value is t. So then multiply this one by cross multiplication, then it becomes AT is equal to v minus u, right, or v is equal to u plus AT, or v is equal to u plus AT. So it is very important for 3 marks, right. In examination they may ask derive v is equal to u plus AT by graphical method. So for that one first we have to write the consideration part. What we have to write the consideration part here? Consider an object is moving with the initial velocity u and uniform acceleration a. Suppose v be the final velocity after t second. So this is a consideration part. We have to write this consideration part, and this part it consists of 1 marks. So after that draw this velocity time graph. This is also 1 marks, right. So next, after that we know that the slope of VT graph that gives the acceleration, slope is equal to BC by AC, then A is equal to V minus U divided by T. So then AT is equal to V minus U, then V is equal to U plus AT. So this is very important for your examination. The next one is S is equal to UT plus half AT square. S is equal to UT plus half AT square. Okay, see here. So here the S means that is a displacement, U indicates that initial velocity and T indicates that time, A indicates that acceleration, right. So in examination they may ask derive S equal to UT plus half AT square by graphical method. Again we are using the same diagram here. Okay, see here. The first one we have to consider an object. It is moving with initial velocity u and uniform acceleration a. Suppose v be the final velocity of an object after t seconds. Okay, see here. So after that this graph, so that is OA is equal to u, then BD is equal to final velocity, BC is equal to V minus u. Okay, see here. We know that the area under velocity time graph gives displacement. Okay, the area under VT graph gives the displacement. So now it is look like a trapezium. Okay, see here. So then displacement is noted by S vector. This is equal to area under trapezium. Right. Okay, see here. So what is the formula we are used to find out the area of a trapezium? Okay, see here, that is 1 by 2 sum of parallel sides into perpendicular distance. Okay, see here, this is 1 by 2 as it is the sum of parallel sides. So here the parallel sides are OA and BD are the parallel sides. Okay, so here OA plus BD into perpendicular distance. The perpendicular distance is AC or OD. The perpendicular distance is that is AC, right? This is equal to. So here we are substituting the values here. OA value. So what is the OA value here? OA value is initial velocity, that is u as it is, plus, so here 1 by 2, sorry. So this is 1 by 2, OA value is u, plus BD value is V into AC. AC value is, that is T, right? Okay. So already we know that the V relation, the value of a V is, that is V is equal to u plus AT. Okay, substitute here, V value is V equal to u plus AT. So then displacement vector, that is equal to 1 by 2 as it is u, plus the V value is, that is u plus AT into T. Okay, I will write here, that is V value is V is equal to u plus AT. Okay, so then this is equal to u plus v means, that is 2u. So that is 1 by 2 2u plus AT into T, right? So next step, that is S is equal to 1 by 2 multiply this one, 1 by 2 into 2 into u, multiply this term here ut, plus 1 by 2 a into t into t. This is equal to, this two get cancelled, then this becomes ut plus half at square, ut plus half at square. So then S is equal to ut plus half at square. It is very important for 5 marks. It is very important for 5 marks. Okay, so there are 2 methods to solve this derivation. So this is the first method. So next I will tell the second method, that is S is equal to 1 by 2 multiply this one, 1 by 2 into 2 into u, multiply this term here ut, plus 1 by 2 a into t into t. This is equal to, this two get cancelled, then this becomes ut plus half at square, ut plus half at square. So then S is equal to ut plus half at square. It is very important for 5 marks. It is very important for 5 marks. Okay, so there are 2 methods to solve this derivation. So this is the first method. So next I will tell the second method. Okay. In second method, so here is same, the consideration part is same, the diagram is also same, and here this point is also same, the area under VT graph that gives the displacement. So in this case we are considering this diagram, we are dividing into 2 parts, one is the triangle, one is the rectangle. Okay, see here, then displacement that is equal to, the first one is area of a triangle, that is ABC, the area of a triangle, that is ABC, plus the area of a rectangle, that is OACD, the area of a rectangle is OACD. So then the area of a triangle formula is, that is half into base into height. So here the base is nothing but AC, the base is nothing but, that is AC, into height is nothing but BC, plus the area of a rectangle, that is ACDO, the area formula is length into breadth, that is AC into DC, AC into DC. So substitute here, this is equal to 1 by 2 as it is, then AC value is, AC is nothing but T. So substitute here T plus, into BC value is, that is V minus U, the BC value is, that is V minus U, plus again AC value is, that is T, DC value is, DC is nothing but U, so this is U into T plus 1 by 2 T bracket of V minus U, right. Okay, see here, already we know that this expression V is equal to U plus AT, right. V is equal to U plus AT. So from this relation, V minus U, that is equal to AT. V minus U is equal to AT. Substitute this value in this expression. So then displacement is equal to 1 by 2 into T. V minus U value is, that is AT. V minus U value is, that is AT, plus this value is UT. In next step, we are rearranging the terms. Then displacement is equal to UT plus half AT square. UT plus half AT square. So these are the two methods to solve this equation. So if you follow any one method, you will get the full marks, right? So it will ask for 5 marks, s equal to t plus half AT square. First we have to write the consideration part. The consideration part is same. Consider an object is moving with the initial velocity u and uniform acceleration a. Suppose v be the velocity after t seconds, right? This is the consideration part. After that, we have to draw this diagram. The diagram is also carrying the 1 marks, right? After that, this point, the area under VT graph gives the displacement. So then, S is equal to area of a triangle plus area of a rectangle. Already we know that the formula to calculate the area of a triangle, that is half into base into height. Here base value is AC, height value is BC, plus area of a rectangle formula is length into breadth, right? So length into breadth, AC into DC. So after that, substitute all the values here. AC is nothing but T, BC value is V minus U, and AC is T, DC value is U, right? So simplify this one. So then S equal to 1 by 2 T into AT, T into AT plus UT. Rearrange this equation, then it becomes S equal to UT plus half AT square. Okay, see the problem here. The body starts from rest, acquire the velocity of 12 meter per second in 5 seconds, calculate the acceleration and the displacement, right? The first, write on the given terms here. See here, the body starts from rest. So rest means the initial velocity of that body is 0. Okay, see the problem here. The body starts from rest, acquire the velocity of 12 meter per second in 5 seconds, calculate the acceleration and the displacement. Okay, first list out the given terms here. So here the body starts from rest. The body starts from rest means initial velocity of that body is 0. The initial velocity of that body is 0. Next, the velocity of 12 meter per second in 5 seconds. So that means final velocity of that body is 12 meter per second in the time interval of 5 seconds. So calculate acceleration. Acceleration is equal to question mark and displacement is equal to question mark. So already we know that the relation between initial velocity, final velocity, time and the acceleration, that relation is V is equal to U plus AT, right? In this equation we want A value. So then A is equal to V minus U divided by T. Okay, substitute here. The final velocity is, that is 12, initial velocity is 0 and the time interval is 5 seconds. This is equal to 12 divided by 5. So simplify this one, we will get the answer is 2.4 meter per second square. The 2.4 meter per second square. So this is the acceleration. Next one, displacement. So the formula is S is equal to UT plus half AT square. This is the formula, right? So the displacement is as it is. So U value is given, U value is 0 and T value is 5. 0 into any term is 0 plus 1 by 2. Acceleration value is, that is 2.4 and time is, that is 5 square. Then S is equal to 0 into any term is 0. So then this is 1 by 2 into 2.4. So 5 square means 5 into 5. Multiply this one and simplify this. We will get the answer is, that is 30 meter. The answer is 30 meter. right? So this is the acceleration is 2.4 meter per second square and the displacement is 30 meter. The next problem, the car accelerates from 6 meter per second to 18 meter per second in 12 seconds. Assuming acceleration to be uniform, calculate acceleration and distance covered in 12 seconds. Right. Okay. First list out the given terms here. So what are the given terms here? A car is accelerate from 6 meter per second to 18 meter per second. So that means the initial velocity is given 6 meter per second and the final velocity, that is v is equal to 18 meter per second. In the problem, that is they are given that body or that car is accelerate from 6 meter per second to 18 meter per second. So then it becomes initial velocity and it becomes the final velocity. And the time is also given, that is t is equal to 12 seconds. The time is given, t is equal to 12 seconds. So here first we have to calculate what is the acceleration of the car, after that distance covered in 12 seconds. So acceleration is equal to question mark and distance covered in 12 seconds is also question mark. The first we have to calculate what is the acceleration. So already we know the relation between u, v, t and a, that is v is equal to u plus at. So from this relation acceleration is equal to v minus u divided by time t. The v value is, that is 18 meter per second minus initial velocity is 6 meter per second divided by time is 12, that is 12. 18 minus 6 is, that is 12 divided by 12. So then acceleration becomes 1 meter per second square. The acceleration is 1 meter per second square. And the second one, the distance covered in 12 seconds. Distance covered in 12 seconds. Okay, the second one is distance covered in 12 seconds. Then s is equal to, that is ut plus half at square. The relation is s is equal to ut plus half at square. Here s is as it is, then u value, the initial velocity is 6 meter per second, time is, that is 12 seconds, the time is 12 seconds, 12 seconds plus 1 by 2 as it is, the acceleration is, that is 1 meter per second square, then t, so that is 12 square. So then s is equal to, this is 12 into 6, 72 plus 1 by 2 into 1 into 144. 144. Okay. Then s is equal to 72 plus 144 divided by 2. 144 divided by 2. So then it becomes 72. This is equal to 72 plus 72, that is equal to 144 meter, right? So the acceleration of that body or the car is 1 meter per second square and the displacement in the 12 second is, that is 144 meter. Thank you.